Hello, this is Mr. Stansbury. I'm going to take you through the 9B assignment. Okay, so let's start with number 1 here. For each of the following graphs, find the domain and the range. Now, remember, domain is what the x's can be, and the range is what the y's can be. Okay, so all we're trying to do is figure out what each of those can be. So, number 1, A domain is going to be. Now, if we look at it, this function starts here and it goes forever and ever this way. So if we're looking at just x-wise, we just want to basically think horizontally. So as I'm here and I'm moving along the function, I'm moving to the right. So that means that I'm starting here at, there's a lot of ways to do this, but I'm going to do this. I'm starting here at -1 for my x, okay? And my x is just getting bigger and bigger and bigger than -1, right? It's getting larger and larger and larger. So x is going to be greater than -1, but it's also equal to, because it's got the closed circle, so x is greater than or equal to -1 for my domain. Okay, you could obviously write it the other way around too. That would be fine. And then the range, as I'm looking at this here, if I'm looking at the y as I'm going on this line here, again, I want to think vertically. Am I going up or down? So this one, I'm going down. I'm starting at 3, and I go down forever and ever and ever. So my y is going to end up being less than. Okay, so my y is less than 3. Okay, so, and it can be equal to, because it's underlined, right? Okay. So, a lot of people will write this the other way around, and that's totally fine. You would write it as x is greater than or equal to -1. That's fine. Sometimes I just kind of like to start on the left and say, okay, what's the point? If I actually am given a point, and so that's why I started with -1 and 3 instead of the other way around. All right, B. Domain is. Now the x here, again, just looking at the x parts, which is, here's my x here and here's my x there. So I'm not worried about the y's yet. That's the range. So just looking at the x's, this thing starts, as I'm going from left to right, it starts at -1, and then my x is in there, and then it ends at 5, right? So now all I got to figure out is, okay, what's happening is it's going from left to right. It's getting bigger. So the x is getting bigger than -1, but it's going to also be less than 5, right? And this one has an open circle, so there's no underline. This one has a closed circle, so you're going to underline this one here. So really our domain is -1 is less than or equal to x, which is less than or equal to 5. Okay? Range. Okay? Now we're not worried about the x. Now we're just worried about the y's. Okay, so again on this one here, I want to look at my numbers here, and it goes from 1 to 3. Okay, so I could just start with 1 here and 3 there, and there's my y. Now it's getting bigger than 1, so my y is going to be greater than 1, but it's going to be less than 3, and again, this has got the open circle, so there's no underline. This has got the closed circle, so there is an underline there. Okay, so y is greater than 1, but less than or equal to 3. Okay, C. Domain on this one here is, again, now we're just looking at x's, so this gets a little weird, but you've got this function here goes forever and ever to the left. It's got the arrow. That means it goes forever that way. Okay, so it's going to -infinity. And it's cruising up here, and we got this line here, x equals 2. This function is going to get closer and closer to this line, x equals 2, but never ever actually touch it. It's an asymptote. Okay, and then it's going to get really close to 2 on here as well, but never actually touch it. And then it's going to go forever and ever to the right, so it's going to go to +infinity. So really, domain, the x can equal any number, all real numbers, except for 2. So all real numbers not equal to 2. Okay? So really a simpler way to write that is instead of with the real number portion in there, just say we are a-okay with just doing x not equal to 2. Okay, and really officially in front of all these, they really all should be x such that and y such that, x such that, y such that, and this is x such that the x doesn't equal 2. So as long as the x doesn't equal 2, then everything else is okay. All right, and then here the range is y such that, and then now we're just looking up and down. So this thing here, look, if we're looking down here, this goes forever and ever down, so it goes to negative infinity, and this goes forever and ever up, it goes to positive infinity. So it really goes, it's all the real numbers, so it's all the real numbers y, except for it's never going to hit this -1, so it's y does not equal -1. Okay? Okay. These here get a little tricky, but we'll practice those and make sure that you get those down. Okay. For each of the following graphs, find the domain and range. So same idea. So domain is x such that, and again, if you look, this goes forever and ever to the left and forever and ever to the right. So the x is all real numbers, right? Okay, and then we've got our next one here. We've got e. Oh, sorry, we got to do the range. A little sidetracked. Okay, so this is y such that. So now, if you'll notice here, the y, the highest it ever gets is 2, and it's getting down really, really close to 0. But it'll never actually hit 0. So I'm going to think of this. The smallest it ever gets is 0, and then my y is going to be bigger than 0, but it's also going to have to be less than 2. So again, if you start with the lowest y value, go to the highest y value, go left to right, it makes it pretty straightforward and easy. So y has got to be greater than 0, can't equal 0 because it won't ever hit that. And then y has to be less than, but it can actually equal 2 because right there it actually hits 2, so as y is less than or equal to 2. Okay, so that was D. E, we've got the domain is x such that, and again this goes forever and ever to the left, forever and ever to the right. There's no asymptotes in there anywhere, so x is the real numbers. And then the range is y such that, and then again, here's the lowest point here. So I'm going to start with my lowest point is -1. I'm not concerned about the x because that's just the domain. So, excuse me, my range, it starts at -1 and it gets forever and ever bigger than that. So I know that my y is going to be greater than -1, and it actually hits -1, so it's greater than or equal to -1. Okay? All right, F. Domain. If you'll notice, this thing is really similar to this, except for it's just flipped upside down. That goes forever and ever to the left, forever and ever to the right. So this is x such that x equals the real numbers, right? Okay? And then we've got range. We start at we don't have a lowest point, but we do have a high point, and that, again, we don't care about the x value, we only care about the y value, right? So right now we know that y is going to end up being less than, because it's here's my, I don't have a lowest point, so I'm just, the highest point is 6 1/4. Y is going to be less than 6 1/4. And it actually is equal to 6 1/4 because it's got that point right there, so it's y is less than or equal to 6 1/4. You could also write 6 1/4 first and say y is getting smaller than, so you'd write 6 1/4 and then do y, and y would have to be smaller than that. Okay? Okay. Let's look at some more. Here's G, H, and I from the same problem. So domain for G is X such that, and let's see, we notice again as we're going left to right here, it starts right here and it never gets, it's never going to the left from there, but it goes up and it's going up here at an angle, so we assume that it's forever going to the right and forever going up. Okay, so we know that we're starting at, the X value is at -4, and then what's X doing from -4? Since it's going to the right, X is getting larger than -4, and since it's a closed circle, it's X is going to be greater than or equal to -4. Okay, range Y such that, so now this function starts here, and again if we're looking vertically, it goes here and it's going up forever and ever. It starts at -3, and then the Y is just getting greater and greater than -3. So it goes from -3, goes all the way up to 2, comes back down to -2, but then it goes up forever and ever to infinity. So we've got Y is greater than -3. Again, it's a closed circle, so it's also greater than or equal to -3. Okay. This one here, H, domain, we've got X such that, and let's see, it goes forever and ever to the left, it's going forever and ever to the right. X equals the real numbers. The book you'll see sometimes says element of the real numbers, and that's just fine too. Whatever floats your boat. I will take equals the real numbers or is an element of the real numbers. Okay. The range on this here is Y such that, and we've got the Y, the lowest the Y ever gets, it's really close to -2 but never actually hits it, so I'm going to say -2, and then Y is getting greater than -2. Okay, and since Y never hits -2, we don't want to put the equal sign underneath because it's just Y is always greater than -2. Okay, and that's the range. I, okay, domain is X such that, so now if you look at this here, it goes forever and ever to the left, goes up here, it doesn't hit -2, but it hits everything in between. It doesn't hit +2, but then it goes on forever and ever to the right. Okay, so it's X such that X cannot equal -2 or +2. Okay, so that's going to be our domain, and then the range is the Y. So it goes forever and ever down and forever and ever up. But this is a weird one because it doesn't hit any of this section right in here, right? So it doesn't hit anything from 0 to -1. So I'm going to actually write this as two different range pieces here. So we've got Y such that, now we've got -1. How about this? We know that Y at -1, it's just getting smaller than that. So Y is less than or equal to -1 is one part, or if you'll notice here, Y is getting greater than 0. Okay, so or Y is greater than 0. Okay, and again, it doesn't matter which way you have these. If you put -1 and then Y, as long as that's flipped around, then you're a-okay. There's no right or wrong way to write that. As long as you've got the Y and the -1 and you got the arrows pointing the right way, but it doesn't matter which one goes first, the Y or the -1. Okay. All right. So that's a lot of domain and range stuff. Again, these get a little tricky, especially that one. That one's kind of a weird one, but that's all right. We can figure it out. So number 2, use a graphics calculator to help carefully sketch the graphs of the following functions and find the domain and range of each. So what we're going to do is pull up our graphing calculator, and if you don't have a graphing calculator, you can go to desmos.com, and that should work out just fine too. What you want to do is turn it on, and then we're going to do Y equals. If you have anything in there, just clear it out. And then we're going to put in our square root of X. If you'll notice, it already says Y equals. So we're going to do Y equals. We just have to enter in the square root of X. So I'm going to do second root, and then here's our X. That's our variable button right there. Okay, and then we can close it. And then just to make your life easy, let's do zoom standard. And once you've hit zoom standard once, as long as you haven't messed with your window, then you shouldn't have to push it again, and it should always go back to that. So there's what our graph looks like. So it starts here at 0, 0, and it just kind of curves up and to the right. So let's draw that, because it does say to draw a sketch, right? So it goes up like that. So with that, we can figure out the domain and the range. Okay. Domain is x such that, and if you'll notice here, it started right here at 0, and it just gets bigger and bigger and bigger. So we've got, you can write it as x is greater than or equal to 0 if you want. That works just fine. Or again, 0 is less than or equal to x. Okay, and then the range, we've got y such that, and then again we start here at 0, and it's going up and up and up and up and up. So y, we have y is greater than and greater than or equal to 0 as well. Okay, that was, let's see, that was A. Okay, so B, let's put this one in. So we will go back to y equals, and we will clear that one out unless you want to save it for later, which you don't need to. So now we're going to do equals, y equals 1 divided by, and it's just a good thing to practice. Whenever you're dividing by something, just put it in parentheses, and it'll always end up right. You don't, this one you don't actually need to put in parentheses, but I'm just gonna get us into a good habit of making sure that we do that. So we do 1 divided by x squared. And if you have any more than one thing in the numerator of a fraction, you want to put that in into parentheses as well. Okay, so we've already zoomed the regular thing to the standard frame, so we're going to just hit graph, and now it's going to regraph that one. So it looks like, kind of hard to tell, but this actually goes forever and ever that way, forever and ever that way. And if you want to know, you can always zoom in. We do zoom in. If you push the enter the first time, nothing happens, but you push it again and it'll actually zoom in. So then now you can see that the graph is coming down and getting closer and closer to 0. So when we're going to sketch the graph here, it's going to look like this. It goes forever and ever that way and up, and then it goes like that and that. All right, so domain on this one is x such that, and then it goes forever and ever to the left, forever and ever to the right, but it just never hits 0. So x cannot equal 0. Okay, and then range is y such that, so let's see, this thing starts here at 0. Well, it never actually gets to 0, but it just gets bigger and bigger and bigger. So we've got y such that y has to be greater than 0. It's not going to equal 0 because it'll never hit that asymptote down there of the x-axis, but it's just going to be y is greater than 0. Okay. C, let's see, let's do y equals, we'll clear that one out, and now we're going to do the square root of 4 minus x, and you're going to want to put that here in parentheses, otherwise the calculator might think that it's the square root of 4 and then subtract x. If we put the whole thing in parentheses, it knows it's going to root the whole thing. Okay. Now, if you remember from the last one, we actually zoomed in, so I'm going to go back to zoom standard. That's zoom number 6, just so it doesn't mess up our stuff here. And look, there we go. It goes from here up like that. It's kind of like this one, but going the other direction with the negative x. Okay. So, and let's see, it's starting at 1, 2, 3, 4. Okay. So we can do this and go 1, 2, 3, 4. And then that graph goes like that. So domain on that one is going to be x such that. And now let's see, if you'll notice, it's at 4 here. And then the x is just getting smaller and smaller and smaller. So I'm going to say that my x is getting smaller than 4, but it actually equals 4 as well. Okay, or you could write x is less than 4 the other way around. That's fine too. Range, we've got y such that, and again we're starting here at 0, and it's just getting bigger and bigger and bigger and bigger. So we've got Let's write this one the other way around just to show both ways. So we've got y is getting greater than or equal to 0 on this one here. Okay? Okay. Let's take a look at the next three. So we'll plug those into our calculator. Y equals, clear that out, and we've got x squared minus 7x plus 10, and we can graph that, see what it looks like. And look, we got a parabola. Okay, and now it's going to be important to know where that goes down to right there. So that looks like that 1, 2, is that -3? It's hard to tell. That's going to be important to know. So, ready for this? This is where I'm gonna teach you some stuff that you're gonna use a lot if you take studies too. We're gonna do second calculate. We want to know what the minimum value is down there. So we're gonna do minimum, push enter, and it's gonna ask you what's the left bound. So they want to know, what you want to do is you want to get this thing up like in the neighborhood, like close to the vertex but not at the vertex. So this is fine here. So it's saying show me what the left of where you want me to find the minimum at. So there's the left. Push enter, and it says what's the right. So now I have to make sure I go past the minimum, and I'm definitely going back up. So that's definitely past the minimum. I push enter again, and it says, do you want us to take a guess? Yes. It actually calculates it out for you, but you push yes, and it gives you a minimum of x equals 3.5. Okay, the y value is not as important, but the x value is what we want to really know. So we got x equals 3.5. Oh wait, yeah, the x. Oh, actually, it's not the x that we care about. It's the y, isn't it? -2.25. So let's graph that thing. Okay, we've got it. Looks something like this. Forgive my awful drawing. And if you remember, it said 3.5 and -2.25. Okay, so that's going to be helpful for our domain and range. Domain x such that. Now again, this thing goes forever and ever to the left, forever and ever to the right. There's no asymptotes anywhere, so x is going to be all real numbers. X such that it really should be x equals the real numbers, right? X equals the real numbers, or x is an element of the real numbers. Range, we've got y such that, now it starts here at -2.25, and then the y is just getting bigger and bigger. So I want the alligator to be eating the big one. So y is on the big side here. So y is greater than, it actually equals -2.25. So y is greater than or equal to -2.25. Okay. Let's try e here. We've got 5x minus 3x squared, and then we'll graph that one. Okay, and then we got another one kind of like what we just did here. So we're going to want to find that maximum because there's a maximum point up there. So I'm going to do second calculate. Maximum. I want to get just to the left of the vertex. That looks pretty good. Push enter. Right bound. I want to get to the right of the vertex. Push enter. Do you want us to guess? Yep. And it's at x equals 0.83 and 2.08. That is a ridiculous one. 5x minus 3x squared. Just making sure I had the right one there. Oh no, I lost my maximum. Okay, enter. I'm past it. Enter, enter. Okay, so we're going to sketch it, and we got 0.83 and 2.08. Okay. .83 and 2.08. Is that what it was? Yeah. 2.08. So domain x such that, and again this goes forever and ever to the left. It doesn't look like it, but it should be going forever and ever to the right here. So it's going to be x such that x is an element of the real numbers, or x equals the real numbers is fine. Okay, range, we've got y such that, and then here's our maximum point here, right? So we've got 2.08, and y is getting smaller than that. So y is less than 2.08 or equal to, because it actually hits that point. Okay? So that's all there is for the 9B assignment. If you have any other questions, please ask in class. Thanks.